Hey folks, good morning, good afternoon, good evening, wherever it is that you're tuning from. I am Luis, and welcome back to the stream. So today we're gonna keep implementing stamina, which is a technique for identifying static malware and performing static malware analysis using deep learning that was recently announced or um, was published, and it was a co effort by Microsoft and Intel. So just to kind of give a brief reminder, so here's what Stamina is. Again, it's scalable deep learning approach to malware classification. Um, Essentially, the way that it works is um, you have a binary file. It's gonna be a text file, a DLL, whatever. And what you do essentially is, give me 1 second. Hey, morning, Daniel. Are you able to hear me, by the way, Daniel? I have the stream on, but I don't think I can hear myself. Okay, cool. Perfect then. Hey, John. Thanks for coming back. Um, okay, so let's keep going here. Okay, so essentially, what Stamina is you do some pre-processing. So you have a binary file, you have some a DLL, you have a text file, whatever it is that you have. And what you do is you take that file and you convert the bytes and you encode the bytes as an image, right? So once you've converted that into an image, of course, you're not going to be able to see the image, just like you would a photo that you take with your camera, right? But at least the encoding, it looks and it's going to show something, and it's going to represent this binary as an image. And what it's done there, once it's pre-processed, you just use transfer learning. You can use transfer learning. So any of the sort of pre-trained models that are out there, some of the model architectures, right, like VGG, ResNet, right? You can use any of those to train a new model, image classification model that is, on these images that represent the binaries that contain malware and the different types of malware. And you can perform classification on that using some fairly standard techniques. So I thought it was really cool. Actually, I wasn't supposed to stream today, but as of Wednesday, I was like, man, this is a really cool project. I want to continue working on this, and let's see how far we get. Again, as I mentioned in the last stream, the part that I think I'm gonna have the most trouble with is trying to figure out how I'm gonna encode these bytes as an image, at least to the specifications. Yeah, at least to the specifications that are defined here, right? So in this paper, it tells us exactly kind of how to reshape and how to transform the data so that we can get into image format. And here it says the image height is calculated as the number of pixels divided by the width. So that's simple enough, or that's easy enough to understand. But then it says if the height of the decimal number, we round it up and padded. If the height is a decimal number, we rounded it up and padded it the extra pixels as zeros. Okay, so if you take these sentences at face value, it makes sense, right? But I guess it raises some questions, which I'll get into throughout the stream. So what I'm going to be doing is I'm going to be using .NET. Specifically, I'm going to try to do this with F#. None of this stuff is particularly much different if you were to do it in C#. But considering that we're doing a lot of F# on the stream, we're going to continue using F#. Okay. So that said, let me pull up the project that we had been working on. And I don't think I pushed my changes from last time. Let me see. Well, I'm doing that, so that makes sense if it's a sound histogram, but it's making sense in arbitrary case. But is this making sense in arbitrary cases? So, Daniel, what do you mean for like arbitrary cases? Or yeah, what do you mean by that? Like, is this making sense in arbitrary cases? Okay, we have our stream projects. Ah, yes. Yeah. Yeah. Um, that's exactly right. Yeah, this doesn't, you know, you're not representing it as an image. And you're right. Like with sound, exactly. You can have a exactly a spectrogram, right? You can make a nice spectrogram, and that's easily interpretable, or at least it makes some sense, right? Whereas here, like how do you even picture a DLL, right? Well, you know, actually, I have an idea. Let me see, hard drive image. I doubt that this is what it's going to look like, but I imagine, I don't know if you've ever seen, there's these, it will look as noise. Yes, exactly. It will look just like noise. I don't know if you've seen, there's these, partition image. There's these images where like it shows your hard drive partitions or like your hard drive and the information that's contained inside it, and it almost looks like a heat map. I don't know the exact term for it, but I suspect it would look something like that. And yes, in a lot of cases, it's basically going to be a lot of noise. So defrag maybe defrag. Hey Brian. Yeah, something like that. Or like this. Um, yeah, this is actually a really good. Yeah, so something like that. Someone could look like humans. Yeah, exactly. Yeah, yeah. And you see how in here, right? There's that white space, if you will. I assume, um, I assume that this is like the empty space, maybe like there's nothing there. And again, since the paper is telling us that you have you're padding it with zeros, right? Maybe we have like a space that's black or like empty, and it's gonna look pretty empty because there's nothing there. It's just padded with zeros. But yeah, I mean, I guess we just gotta figure out how to do that, and once we do that, then we'll kind of see how or what this looks like. Okay. So, all right. So let's get started. Let me open up the project here. CT. Let's see. Let me push the latest changes first. Get ignore, FSX, get updating last stream's changes. So let's see, get status, get push master. All right, so I push the latest changes, and if I open code, let's see now. I'm in the wrong screen. Okay, so last time where we left off was we read a file, which that's fairly simple enough, or at least we read the bytes from the file. But now the part that is a little bit more interesting, or where I do suspect that I'm going to run into an issue, is making that conversion, right? So we have this binary file, and all it has is the quick brown fox jumped over the lazy dog. So what I'm doing right now is I am actually just I'm doing a test to see if can we convert these bytes, the bytes from this file into an image. But what I really want to do though is there is a data set. Let me see. Kaggle malware analysis. There's a data set actually published by Microsoft a few years back. They published it on Kaggle as part of a challenge. And I think that this gets at exactly what we're trying to do. So if we take a look at the data, right? The data here, it's uncompressed. It's actually a lot of data. I might actually have to spin up a VM for this, right? There's 35 gigs, and that's compressed. So when we uncompress it, it's gonna be a really big, a large amount of data. Okay. And if we take a look at this, right, what the data looks like in this particular data set, it says you are provided with a set of malware files presenting 9 different families, right? So you have an ID, you have a hash to uniquely identify the file, and you have a class, right? So it's one of these malware families, one of the 9 family names to which the malware may belong to. For each file, the raw data contains a hexadecimal representation of the file's binary content without the PE header. And you're provided a manifest with metadata. So it looks like once we figure out how to get this working, how to convert this image, and figure out how can we train it, an image classification model for this particular problem, what we can then do is we can take a lot of that same logic and apply it to this data set, or at least I think it should be simple enough to translate that in a fairly quick, and without too many changes to our code. So let's go back and take a look at the code. So right now we're at the stage, like I said, if we look at our program.fs, we're at the stage where we're just loading the binary or the bytes. All right, and if we were to inspect that, this is it. And the way that I'm going about this is I'm using Ionide and the F# Solution Explorer, and I'm going to use it to debug and see what this looks like. I don't know if it's because I'm streaming, but my computer seems to have a really tough time even doing simple things. Our algorithms involve converting words to binary numbers. Thinking out loud here. I don't know, Daniel. That does sound like an interesting way to go about it. But then I guess what would... Oh, okay, yeah. So I see what you mean. So in this case, it's text. So I guess I could see how we could use something like n-grams or to sort of digitize or convert these values into numbers. But I think, well, I mean, yeah, I guess a binary in this case for malware, right? Like, for example, if you were on the internet and somebody wanted to inject malware into your PC, right? It's not gonna be specifically a DLL. It could just be as simple as like, hey, download this PDF, or like, the brand new book is available for free only here, and just download it now. And once you download the PDF, right, the malware could be embedded inside of that. So yeah, that could be something that we could try at some point. The paper itself doesn't say to do that, but I mean, there's no reason why we couldn't try something like that. Let's see. Let's see, what do we got going on here? All right. Whoa, what happened? Okay, so step over. What do we got? So we have 43 bytes. Okay, so 43. Now, if we go take a look at the paper. Okay, so let's see how it does. Preprocessing the image. Pixel conversion, reshaping, and resizing. Given a binary application, pixel conversion is straightforward. We read every byte into a value between 0 and 255. Okay, that's exactly what this is doing. Directly corresponding to pixel intensity. This step converts a binary into a one-dimensional pixel stream. Okay, we got that. In order to apply transfer learning computers, we need to reshape the pixel streams into 2 dimensions, the width and the height. Were determined by the file size after converting the pixel stream following an empirically validated table. Okay, our table is a multiplier of I, so the relationship scaled helps set the width correct concretely. Okay, so if our pixel file size, which I believe it means this byte array, right? If that's what it means, then 43 would be right here, which means that our image width should be 128. Okay. So we know that our width is going to be 128 for in this case. Okay. So we know that it's 43. Let's go back here. All right. So just add a note here. By a 43. Okay. Now we know that the is going to be 128, and I'll fix this later to make it more dynamic, right? Because eventually what we're going to want to do is we're going to want to select it, right? Depending on the size of the array, whether it's between this, and so forth, we're going to want to select the width accordingly. But in this case, let's figure out how to get this one file converted. Okay, so we have an image of 128. Now here it tells you how do you get the height. Now the height is calculated as the number of pixels divided by the width. Okay, easy enough, right? So in this case it would be binary file. Can you do length on this one? Yes. Let image height is equal to binary length. Okay, divided by g width. Okay. All right, simple enough. So this gets us into the area where I was saying before that there was a problem, or where I thought that there could be a problem. Okay, right, and it's not very clear here, or unless maybe I'm reading this wrong, and you folks in the chat can maybe make sense of this. Okay, so it says if the height is a decimal number, we rounded it up and padded the extra pixels as zeros. Okay. Now, let me pull out the handy dandy Excel here to show what exactly performing the calculation to figure out the height does for us here based on what the paper suggests. Oops, that's not what I wanted. So, okay, so let's say that, let's choose some random numbers. So let's say there's 32, 64, 28, 256. Let's do these first. So let's say that this one's 5, let's say that this one's 11, this one's 32, and this one's what? 156, okay? So if we do this, pixel size, and then width, what's going to be our height? So if we divide the pixel file size divided by the width, okay, it's less than, number one, they're all a decimal. Okay, so that's, I don't want to say problem because they tell us how to address this problem. But as you can see, they're all going to be a decimal number, right? And we round it up. So, okay, fine. So if we round it, equals round this, comma 0. Does it round up? I think we need to do ceiling. Yeah. Oh, thank you. It's been a while since I've actually used Excel. Since my finance days, I've lost touch. Okay, 1. Okay, so we round up, right? Okay, cool. So they all round up to 1. So if we round it. So you know, if what is it? The dimensions. It's when you specify the dimensions of an image, right? Is height times width. So then, would it be 1 by 32? I don't think that that's the case, right? Because typically, when you have an image, you have typically you have proportional dimensions, right? So you have a 32 by 32, or 64 by 64, or 128, and so on, right? So what I think they mean is they want 32 by 32, in which case the remaining 31 here are padded by, they're padded by zeros, right? It's padded by zeros. So I think that's what they mean, but it's not very clear for this. Actually, let me keep reading just to make sure that I'm not missing anything. So consider resizing so that they can be used for transfer learning techniques. Resizing preprocessing does not negative things like classifications. Our system trains. Our system can outperform any other. Okay, fine. Furthermore, for malware from the same family, resizing will result in similar patterns. So they do this. So once they figure out what the dimensions should be of the original image, they go ahead and resize them so that they can perform transfer learning on these images. We don't care too much about this. The reason is with ML.NET, which is what we're going to be using for doing the transfer learning, it automatically resizes it for us depending on it automatically resizes the images that we give it to the specific architecture that we're going to be using. So this isn't too much of a concern. We can literally feed it just as, you know, the 32 by 32 in this case, or whatever the dimensions are, and we can feed it. We can feed it this data, and it will automatically resize it for us. So what I'm thinking here is, so let's say that we were to take an 8 by 8. So 1, 2, 3, 4, 5, 6. Let's do a 4 by 4 actually, just to make it simpler. And the way that I envision this happening is we have, let's assume that the first 3 are bytes. So then to convert it into a dimensional array, be 0. We're going to need it to wrap around. We're going to need to wrap around and do something like this. So let's imagine that we had a byte array with 3 pixels, or with 3 bytes, right? We would do this, and then everything else gets a 0. So how would we go about that? If we know, let's go back to the code. I think this makes sense. So math round. Put this round down. Let's see. I don't know actually what this one would do. Math sharp round up. Round up. 3.212. Yeah, but I wanted to round up though. There we go, ceiling. Will this work? Well, this is one of the nice things about having the REPL, right, is that we can literally come here and try it out. So let me get rid of this, make more room. Okay, so this one of the nice things about the REPL is that we can kind of try it out without having to run this. We can just essentially do this, right? So open system.io, and then we can just say open it. And what we're using here is we're using Ionide, right, to perform some of these operations for us. Ionide is this plugin extension for the editor that basically transforms your VS Code, in this case, into a full-fledged F# editor. I don't know why it does this, why it tries to start Anaconda. Okay, so that worked, I think. Gonna have to figure this out at some point. Stop due to what? Stream projects. Let's see, print append %s source directory. What do I get when I run this? Yeah. Is it because of where I am in the file? This here tells me it can't find it because it's not in this top level folder. But here it's telling me that my source directory. All right, fine. We'll just do it. Let file path is equal to source directory plus my binary.txt. Okay, so let's do that. And then let's just print out the file path just to make sure that we got the right path. Okay. Oh. What am I looking at here? Hi F319 Troy. So what we're doing here is we are using F# and .NET. We are trying to implement Stamina, which is a static malware. It's a static malware analysis technique that was recently published by Microsoft and Intel. And what this does is it uses transfer learning and deep learning to classify malware, right? And the way that it does that is by taking a binary, converting it into images, and then feeding it to some sort of pre-trained network to perform transfer learning on it and be able to then classify whether, number one, whether it's malware, and number two, which type of malware family this particular binary belongs to, if it indeed is malware, right? And right now we're just doing a quick test to see how we can implement what the paper says, or implement the technique that the paper suggests for doing this. But later on, what we're going to want to do is we're going to want to essentially go ahead and use this data set that's on Kaggle to sort of do it real time. And I do not want to become famous, and I don't want to buy followers. So that's that. All right. So let's see. So let path. Okay, path. Path dot. Let's just do that. I was being lazy, but yeah, let's do that. And then this, let's change it to file path. Okay. All right, cool. Okay. So this is what my binary has. Now what I need to do is, if I know that my width is equal to 32 in this case, right? Or width. So then the height is equal to, it's going to be equal to binary file dot length divided by img width, and then so we're gonna pipe this into the ceiling function. Oh, it's ceil. Okay. The type int does not support the operator ceiling. Okay. Is it an int though? Oh, all right. Even better. It rounds up automatically, so we don't have to do it. Okay. Awesome. Yeah, that's true, but oh, actually no, it wasn't 32. It was 128. My bad. Okay, yeah. So it's 128. So what do we get when we do? Well, when we do this. There we go. So we convert these to floats. And then what we can do now at that point is just pipe this to seal. Cool. Perfect. Just what we want. I'm wondering if we even have to do this though, because as we saw here when we were looking in Excel, it's always going to be 1. So, I mean, I guess the only scenario where this wouldn't be true is here. In this case where it says, okay, if it's greater than 1500, so it could potentially be that you have, I don't know, 3,000 bytes, and then divided by 248, you're over 1, right? So in really big, for really big images or for really big files, that's where this would come in. But otherwise, I don't think so. All right. Okay. No matter. So what we want to do is we now want to create a 2-dimensional. So convert this 1-dimensional binary into 2 dimensions. So right now this should be 43, right? If we do, let me just do it here because I don't feel like binary file dot length 43. Perfect. Okay. So what we want now is we want to be able to, let me just make sure, percent a binary file. Okay, that's what it looks like. Okay, cool. So now what we want to do is we're going to want to have this, wrap around. So we're going to want to create, for example, if it was we want to create a list or an array in this case, right? So the way that we could do this is we can take binary file, and then so we can get so lappad is equal to binary file dot length minus length. Okay, so this is what our pad's going to be. So because this, the length of this is 43, right? We have 85 values that are going to be zeros in this first I guess row, if you will, right? So the way that we can do this is we can do image with what are we doing here? So we want to pad it. So what we can do is binary file, and then we can concatenate it with array.zeros pad. Let's see. Oh, 0, 0, create. Value is not to have generic type. Okay, so you want byte. There we go. Okay. So now what we've done is we've created, and if we were to pass this to array.length, there we go, 85. Okay, so now we've created the remaining part, right? So it's I believe it should be 128 by 128. And we know that the binary file, let me actually, binary file bytes, just to make it clear, because it's not the file, this is the bytes, right? So let me just run that again. And we know that this, we know that this is 43, but it needs to be 128. Like it's one row is 128. So what we do here is we create or we pad it with the remaining amount. So 43 or 120 minus 43 is 85. So this should give us, if we were to do, if we were to print this out, right? So let ng is equal to, I thought that this was an array. Oh, sorry, no, not this one. Oh, that's why. Binary file bytes. So what's binary file bytes? Binary file bytes. I want to see what type it is. Yeah, it's a byte array. This expression supposed to have type A list, but here has type byte array. Okay, can't you append to it? What platform this malware is? I'm not particularly sure what platform. In this case, all we're doing is we're taking a, we're just taking this text file, right, which contains the text here, and we're just trying to figure out how can we convert it or encode this into an image as specified by the paper that was published, or the white paper. The data set eventually that we want to use is this one from Microsoft, but it doesn't necessarily say where or what type of malware it is. These are the families that the malware belongs to, but I'm not sure, you know, I'm not an expert in malware, so I couldn't tell you, you know, is this like a Unix or is it Windows or whatever it is. So I couldn't tell you. But essentially, eventually, what we're going to want to do is we're going to want to be able to classify the binaries into one of these families. But for the time being, we're just trying to figure out how can we get a one-dimensional byte array representing the file into an image. Okay. So here it says this expression was to have type A list byte. I could have sworn that if you did this, right? So let's take an array just to prove a concept. 1, 2, and then you did 3, right? You can only do this on lists. That's not right. Let's see, concatenate F#. Oh, it's not a list. It's an array. Cannot resize arrays. There is no source array because of no type system. So it's only with lists. Array. I want to do an array. F#. Okay, that's one. That's one. Array.0 create. Accessing modules, functions that create arrays. Yep, that's fine, but that's not what I'm interested in. The following is array.append. So I do have to call array.append. Okay, no worries. I could have sworn that you could have used the at to append values, but it's fine. I can do this too. Okay. First row. Oh, yeah, that's right. So it appended it to the end when it should be the other way around. And the reason for that is, when you use the pipe operator, this is the first value, and anything that you pipe in becomes sort of the second value. So that's why it took this one and then it appended our actual binary bytes into the second, or pass it in as a second parameter to append. So what we need to do is we just need to reverse these. There we go. Okay. And now if we're to do first row dot length, right? It should be 128. Awesome. So now what we have is we have a 1 by 128 here. So now we just need to pad the rest with, so let's remaining rows, I guess if you could call it rows, sequence. And what we can do for that is we can use list comprehension. So array dot zero create byte by image with let's see, how do you do list comprehension here? Where's the list comprehension? For, okay, I got it wrong. So it's this. For I in 127 do, no, it's not do. Okay. So many rows. There should be 127 of these. 128. Fine. Off by 1. Wonder if I do this to then I do this. Oh man, where has the time gone? It's already 10:49. Okay, so 127. So then what we can do is then we can just append, right? So then we just do first row array dot append remaining rows. Whoops, the other way around. Just to make sure, let image bytes equal to. Okay. What are you talking about? Oh, subtleties here. So I created a list instead of an array. And the array, right, we make it just by adding those pipes there. So then if we go here, whoops, no. Makes absolutely no sense. Remaining rows. Okay, yep, it's an array of arrays, and I want to append my first row, right? Which first row, we know that it's an array of bytes, and this is an array, a two-dimensional array of bytes. So what's the issue? I really don't want to. Oh, type mismatch. Expecting a byte, array, array. Yeah, but I'm just trying to append to this array. Like, just want to add on to it. Did I miss something here? Okay, so it's 127. Just make sure something here. Okay, and then this itself is an array. So 1, 2. So int array dot append 1. That makes absolutely no sense. That makes no sense. I want to append an array to the two-dimensional array. So it should just be another entry in it. Why does it have to be a two-dimensional array itself? Okay, fine. So now I have the image. Fine, let's assume that now we have the image. Now I want to save it. Where do I want to save it? Well, first of all, how do you convert an image? So the way that I think you convert an image is using system.drawing, right? And then, oh, not using, it's open. C# is creeping in. So open system.drawing. And then what we want to do is we want to do image dot from what? I think it's image from stream. So we have image methods. There's from file, no. HBitmap, no. From stream. Yeah, I think this is what it's going to be. It's going to be from stream. But we want to make sure that we dispose of it correctly. So oh, is it as simple as that? Use. could do that, but no. It's a idiomatic. What's the difference? So the use keywords for the enables to that resembles that of the let, provides the same functionality as let binding, but it adds a cost to disposing the value when the value goes out of scope. And sends a null check when the value, so that the call to dispose using file instructions automatic. Okay. So implicitly goes out. I don't know. I don't trust it. Maybe it's C# telling me that I kind of want to have this. That way I know that the scope is within this. Let's try it. Let's go with this. Use. So let's go with use. Memory stream is equal to memory stream. Oh, I'm going to need open. Oh, I already have system.io open. So memory stream. And then we want to pass in image bytes as our bytes. And then what we're going to do is we're going to do let mg, let ing is equal to image.from ms, right? And then what we're going to do is image.save, I don't know, image.jpg, something like that. Okay. All right, so we know that there's 128 here. This. Okay, what's going on here? Type of our memory stream. It's a byte array, so we need to flatten it. Okay, no problem. So file let flattened image is equal to oh okay, yeah, let me go about this, but I don't think that this is right, that I created an array, because if it's going to be flat anyway, I might as well just take what, yep. Yes. Yeah. Okay. That's exactly what I could do. So I know what this is. I know what my image width is. So I know what my height is. Actually, does it even matter that if I know my height? If I'm just going to pad it? Yeah. I'm only going to comment this out. I'm making this way more complicated than it needs to be. If I just need a one-dimensional array to pass in here, well then in that case, get rid of all this. I know that my image is 128. We're gonna go and make the assumption that this should be 128 as well, which is exactly what we did. So if we know what let dims equal to 128 times image height. Okay, so if we go here, it's 16,384. So there should be 16,384 bytes here, right? So then what we do is we just take so let pad is equal to binary file bytes, or better yet, dims minus, right? Because we want to know how much are we going to pad, and then all we need to do is we need to tell it let image bytes is equal to this thing here. Okay, and we pad. Okay, so our pad now dot length. Okay, 341. Okay, Now if we're to look at image bytes dot length, it should be equal what, 16384. Boom, there we go. Nailed it. Nailed it. So then we can get rid of all this because we can. System.drawing. Okay, memory stream. It's recommended. Warning. It's recommended support. I suppose once it's created is fine. So new. Let's go with you. Did I do that? Image. It's not defined. But I did though. The image class system.drawing.common. Oh, yes. Okay. I would do packet, but let's see here. Basically what we want to do is we want to be able to say cd stamina. Why does Conda like to... I need to fix a few things with my PC here in my setup because I don't know why Conda keeps trying to activate itself. So we're going to do cd stamina and then cd app .NET add system.drawing.common, right? So the reason why we're doing this is with .NET Core, system drawing common is now a it's just a NuGet package, right? So you have to install it. It doesn't come. It's not part of the base class library. So now that we installed it, we need to now pull it in here. So that NuGet, right? Let's see. NuGet packages. Okay. So I want to include this. And then what I want to do is I want to reference, what is it? System.drawing.common. Where is it? There it is. System.drawing.common, system.drawing.common. Essentially what we want to reference here is the DLL. So 4.7, 4.7.0. Is that right? Yeah. Lib net standard 2.0, and then what? System.drawing.com.dll. Actually, I wonder if I can just do this. So typically with F#, if you wanted to load stuff into script, you had to kind of reference the DLL directly. But there's a new way with F# 5.0 that where you can just do this. NuGet system.drawing common. Oh, I need to be running my FSI. Okay, so I can't do this because my my F# interactive is not running the preview version yet. But this is how you would essentially do that, and you sort of save yourself having to figure out where your DLLs are and things like that. So it's really neat. Yeah, that's actually how Jupyter kernel does that, Daniel. Right? So you have the R, I believe it's the R. Yeah, like reference, and you tell it select from this place, and then you just give it the package name, and you could also specify, for example, if it was, you know, version 4.6.1, you could reference it that way. But for the time being, let's just keep going here, and let's do it the way that it usually is, right? So now it's referenced, and now think I should be able to do this. Oh, from stream, that would help. Okay. Come on. System.drawing is not supported on this platform. What are and I when playing with Jupyter for .NET? Now it makes sense. Yeah, yeah. That's exactly what it means. This is just basically like an include, right? Like basically, so what happens is anything that you pass into R, what it does is it has a list of predefined packages, right? It's almost like a path, right? So at least with F#, that's certainly true, and I assume that with the .NET Interactive, that's kind of how it does it. And Jupyter Notebooks is it has a sort of a like a path, if you will, right? Like a path environment variable, and it will look through all the folders that are part of this path like environment variable, and it will try to find the DLLs that you're trying to reference in those paths, right? Exactly, yeah. So load is if you're doing scripts and actual files, and then R is for DLLs and packages. So the way that you can add on to that path-like environment variable, right, is you just do £i, and now it's going to look for the DLLs in this specific like folder. And the reason why I did it as sort of a top level is that that then I can just reference the specific package that I'm looking for, right? Because otherwise I would have to add on this thing as well, right? So that's kind of how that works. Okay, but now why is this not working? System of drawing is not supported on this platform. That's not right. Net standard 2.0. Let's go back here. Image class provides bitmap and meta file. System.drawing.com. Namespace system.drawing. Yeah, that's what I did. Why does it say it's not supported on this platform? Related to net standard, the exception I mean. It could be. Yeah, let's try it. 4.70 system drawing. 47 lib. Let's try net 461. I could have sworn that it was part of .NET standard. But I bet you that if I do this here, watch. So let's take this code, and so this is where we read stuff. This is where we did this, right? Let's copy and paste all over the place. So image width, image height, binary file, bytes. Okay. All right, cool. Now, if I were to do this, all right, open system.drawing, I bet you it would work. Right, I can't open it inside of here, but I could do it here. Okay. And then if I were to sort of switch over to PowerShell, build, and then it should run. Why it's not working in FSI? That is a good question. I'll have to figure it out. Parameter is not valid. Line 21 from stream boolean use embedded color management. Validate image data. Let's say no. Validate image data false. But then that means that I have to x equals false might be able to refactor not x. Okay, from stream. Stream IO system drawing image parameters that contains data for this system drawing image. Does not have valid for stream. Takes one argument. Okay. Image class from stream properties methods from stream true false. Oh, true to validate, otherwise false. I don't know what the default is, but let's go with true false. Let's try this. Code is being used by another process. Okay. Which process is that? Oh, I think I might know. Let's get rid of this. Okay. Run it. All right, time to switch to T for coffee. Parameter is not valid. Check status from stream. Okay, close the program. So it's line 21. So it's exactly this that's giving us a problem. Parameter is not valid. Let's see. All right, so we have, let's do another 15 minutes here. So there's just one thing that I was looking at actually. Image converter. C#. There's this other thing. Let's see. Image converter is a class of use to convert image objects from one data type to another. This might be something that we might want to use. Image converter. Okay. First of all, we check whether we can convert it. And then convert from. What does this return though? Turns an object. SAML is behavior enables converter type attributes. Convert from string. Convert to converts an image or an object that can be cast to an image to a specified type. So I don't want to convert to, I want to convert from. Could it be as simple as that? Convert from, pass it the object. Oh, let's try it. Let's see. Converter. System drawing. System. Oh, I see. It's a platform extension. So it might not work in this case. System.windows.extensions. Yeah, but the other thing here is that we would like this to be cross-platform. So if we were to sort of bind to Windows, that means that we could only run this on Windows. So maybe this is not exactly what I'm looking for. Let's keep going down this other rabbit hole, right? So what was it? Parameter is not valid. Unhandled exception. Let's do the handy dandy. Image null from base 64. So HTML5 canvas 64. Okay. So problem, I guess, is really a bit of image form which image class doesn't recognize. After inspecting it a little bit, I be able to your image. Okay. Things. This gives me a good view closer. So something, but doesn't change the colors though. RB and swapped. So you have a little bit of set pixel. Awesome. Thank you so much. That you have algorithm reference bitmap data spec review. What is this from? Oh, this is 2011. I'm not going to discount it, but it's a little dated. Bitmap. Okay. Parameters. I'm maybe saying okay. Okay. Status GDI. This basically checks managed code to see throw AE. Is it still open? It is still open. Core effects. I wonder what this looks like. Core effects. And then the issue number is 41527. Oh, it's going to be in the runtime. Okay, to develop code and issues. Okay. 41527. What is it? 41527. Yeah, that's not right. Let's try it. What was it? Parameter not valid. Bitmap clone out of memory, out of bounds. Let's go back here. Image not from. Oh, this seems to be a fairly common. Yeah, exactly. So this is what we're doing, right? We're doing a new memory stream, byte array in. I'm getting this exception despite the fact that no value is greater than 255. Okay, please, it's very strong. It's double. Okay, fine, phrasing. All right, I have the same problem. Apparently, it's solved now. Despite this, I have some GDI exception variables. I found the actual problem was that the parameter being sent to a bitmap conversion was not valid. I had this code. File stream, okay, input image, file. Access read write. Yeah, but it's not a file stream. Using bitmap fs true false. Okay, the following was causing error. The file was downloaded from the maps from my app was sending the JPEG extension telling me that error occurs. So obviously I'm trying to control validate the image for a valid JPEG image. So there's that image converter that I was talking about. This working solution. Thank you. Got a few types of image to load and some that couldn't load by image. The image converter can load them all. Okay, so it looks like image converter might be, but I don't want to do that because, like, again, I want this to be cross-platform. I don't want it to be tied to Windows. It's not great. Which of course automatic by as most often binary actually contain image in a sensible format. For example, the following works fine. but it has images. That's the thing. Let's see, stream. Let me take a look at what this does. This does. True, the color management is better in data stream. Otherwise, false. And what was this person trying to do? Yeah, I mean, I think in this case it's a little bit, it's similar, but at the same time it's a little bit different. Um, because in this case they actually have an image. In my case, I don't have an image. I just have bytes. I have bytes. Oh, that's a cool background. Nice. I have bytes that I want to convert into bytes byte array to image. I mean, I'm pretty sure what this is gonna show me is right, exactly. Like that's what it's gonna show me. Code base when I get a byte array. Yeah, memory stream. I mean, that's what we're doing. Memory stream non-writable if they're interested. It was on the stream longer no stream converter. Convert from JPEG byte array. Maybe I'm asking the wrong question here. Okay. Byte array from text file to image. Byte array input stream, embedded, get image, embed message. I wonder if there's like some sort of header or some indicate like when you encode JPEGs or any sort of image file, I wonder if there's something in the byte array that lets it know, yes, this is an image. From my understanding, the answer to that is no. But I could be wrong. Let me actually see. How do they do it here? Extensions catalog, ADN if he tries, extract pixels, D9 if he tries test. Try that, convert to image. Ah, there we go. We could probably do this, convert to image. But I bet you yeah, so in this case, you got features. That they turn into pixels. They convert into an image. Image hides features to an image, and then yeah, but then again, that assumes. Could it be as easy as this? Let's try it, actually. I mean, Maybe I don't even have to bother with turning it into an image. Maybe I can just pass in the pixels, and then I can use ml.net to handle everything for me. Let's try that. Okay, so get rid of you. And what we want to do now is .NET Append. I wonder if I have to install image analytics for this one as well. I think I do. Let's see, .NET App Package, Microsoft.nl.image analytics. All right. So open Microsoft.nl. All right, so let's just make it really quick. Let's try the other way it works, from image to bytes. Yeah, from image to bytes. I mean, yeah, it does. I mean, because essentially here what's happening is you're feeding in an array of, well, in this case it's an array of floats. But it's almost the same thing, right? And then you feed that, you convert it to an image. So you take features and convert it into image, and then image, you extract the pixels and you get that back out, right? And in your image is this thing here. So yeah, it could work. Could work. Let's see this. But now I need to create what's it called? Now I need to create a CLI mutable, and then type, I don't know, image, and then byte features. Whoa. I'm writing C# again. Byte array. Not a valid use in this language. We might need to convert to vectors first, but let's see. Yeah, you're right. Maybe. If only can get past the CLI mutable is not a valid use of the language element. What are you talking about? Oh, it's equal to. There we go. Okay. Features. Yeah, I think this should be good enough, right? So. Oh, that's not what I wanted. I did not want to. Okay, that's not what I wanted to do. So image. So then what we want to do here is we want to do ML context. So we'll do CTI equal ML context. Now CTX dot let EDV is equal to CTX dot data dot load from enumerable. Yeah. Load from enumerable, and then we can just tell it this thing here, right? We're gonna create a, well, will this work? I don't think so, because these are not interoperable with, but let's try it. I mean, who knows? And then features equal to what? Image bytes. Now let's pipeline is equal to what do we want it equal to? It's equal to estimator chain. I need to do open Microsoft transforms. Where's the transforms? Transforms, I think it is. Oh, and I don't need this because this is not C sharp. What does estimator chain belong to? Estimator chain. Oh, L data. Interesting. Okay, sure. Open Microsoft.ml.data. Estimator chain append. What we want to do here is we want to do ctx.transform.image convert to image, and what we want to convert to image is, oh, there it is, image height. I'm gonna go with 128 by 120. Well, I'm gonna go with 128 by 128 by what? Show me. Show me. Where'd IntelliSense go? Fine. So we need height width, the output, which is going to be this thing called image, and features. Okay. Happy? Oh, right. I need to instantiate it, I think. There we go. Okay, so here's our pipeline. Why doesn't this work? It's weird, but okay. And now what we want to call pipeline.fit. So, I don't know, let transformed is equal to pipeline.fit idv dot transform idv. And if this doesn't fail, then we're good. Let's see, .NET build. The problem with this, so I could already see what a problem. Well, yes, I already see a problem with this, but first let's figure out if we can actually run it. But there's a problem right off the bat, and I'll tell you in a bit once we figure out if this is gonna fail or not. Expected. Oh, yeah. Okay. So, kind of what you were saying, Daniel. We might need to tell it that it is a vector. Got var vector of bytes, but expected a known size vector. Okay. So, what's 128 by 128? 16384. Right. So, var, what is it? Vector type, and this is an attribute, so vector type. And what was it? 16384, right? 16384. Just confirm my handy dandy equals 128 by 128, 16384. The old noggin still works. Okay. And yeah, so now that we know that that's what it is, let's try it again. So now we know that it's a vector. Got a var vector byte. But I told it that it was, I mean, .NET Run should run .NET Build already, but it's not right. Okay. All right, so I guess we'll just have to keep this debugging this later on. And as expected, this is really going to be the biggest hurdle here. Like, how can we get these bytes into an image? Because once we got the image, then we can just call the image classification transformer and just have it go at it at the data, right? So that's going to be easy. But this is really the part. Like, once we figure out this part, we should be good to go. Now, before I was saying that there's a problem here, and the problem is when you define a pipeline, it's, how should I say this? It's static, right? So when you define a pipeline, it's static. In this case, I hard-coded 128 by 128 of which are the image dimensions. And that's fine because in this case, I know what I want the image to look like. But if you recall, the width is dependent on the size of the pixels, right? So the as it was shown here in the paper, right, we have to sort of abide by this table, and that's how we were able to figure out what the width is. And the problem with doing it as part of the pipeline is we can't dynamically change what the pipeline will size the images to. I guess what we could do is we could we could try to see if maybe just setting them to 128 and just being very generic about it will work, but that's not what the paper suggests. So I suspect that we might run into an issue here. Yeah. Yeah, we might run into an issue. So I think that's why we can't do it like this. I don't want to say we can't, but we might have to rethink of how, if we were to be able to do this with ML.NET and to convert to image transform, we might have to rethink how we might go about that. But then the other easy, quote unquote, easy alternative is we would actually have to turn it into an image and save it onto disk and then load from the images on disk, which is not what I would want to do. But it seems like that might be the better approach. But anywho, I went way over. I was actually just thinking of doing this until 11, and it is 11:38, and I have to go. So what we'll do is we'll continue. Well, actually, on Monday, we won't continue on this. On Monday, what we're going to continue doing is we will continue working through the workshops that we were doing before, right? So we're going to be going through the Microsoft Reactor workshops, and again, continuing to improve. I'm going to continue to improve my F#, hopefully, and learn some data manipulation and some libraries that will help us perform that data manipulation and data cleaning using .NET, specifically F#. So we're going to continue doing that on Monday, and then Wednesday we'll get back to this. I suspect on Monday I might want to come back to this, but we'll see if we have time. Anyway, thanks again, folks, for joining. I hope that you learned something, even if it's what not to do. I certainly learned a thing or two, and this problem is definitely, I'm going to keep thinking about it. Definitely over the weekend, I'll keep sort of looking stuff up, and hopefully next week I can come back with a better answer as to how we might want to approach and how we might want to handle this pre-processing of data and converting it into images. In the meantime, again, I just want to thank you again for joining, and I'll see you next week. Have a good weekend. Bye.